Hello everyone, welcome to Mannem Java Central. Myself, Mannem Prasad. In the last session, we have discussed about the Java 8 default and static methods of interfaces in a very high level. If you didn't watch that video, I have left that link in the description. You can watch it. Now in this session, we are going to discuss about method references in Java 8. As usual, we can continue our discussion based on three principles: why, how, and where. That is, why method references introduced, how to implement method references, and where to use method references. This session will also cover the famous interview question, what is method references in Java 8 and how it is useful to the developer. So without any further delay, let's quickly jump into our topic of method references. In this session, we are going to discuss about method references in Java 8. So before going to discuss about method references of Java 8, first we need to see what is functional interface and what is Lambda expression. So what is a functional interface? An interface that contains exactly one abstract method is known as functional interface. Functional interface is also known as single abstract method interface or SAM interface. Because functional interface contains only one abstract method, that's why it is also known as single abstract method or SAM interface. Let's see the code snippet of simple functional interface. See here, order product is a functional interface. How can you know that this order product is a functional interface? Because order product interface contains only one abstract method, that is a order capture. And moreover, this order product functional interface contains functional interface annotation. By seeing this functional interface annotation, we can confirm that order product is a functional interface. And the next one is, what is Lambda expression? Lambda expressions are used to provide implementation to abstract methods of functional interfaces. Here, Lambda expressions are used to provide implementation to abstract methods of the functional interface and assign that Lambda expression implementation to the reference variable of functional interface. And then wherever you need to call that methods in the functional interface, then you have to call that methods using reference variables of that functional interface. See the small snippet of code. So here I have provided implementation for order capture of functional interface in the form of Lambda expression. And after providing the implementation, I have assigned this Lambda expression implementation to reference variable of functional interface. And then I have called that method using that reference variable of functional interface wherever you need. Let's see this example in the IDE. So I have a functional interface order product. And this interface contains the abstract method void order capture. As this is a functional interface, we can designate this functional interface using the annotation functional interface. And for this functional interface, I can provide implementation using Lambda expression. So see, first we need to create reference variable to the functional interface, order product is equal to, and right here, Lambda expression implementation to abstract method of that functional interface. And into implementation, arrow operator, and provide implementation. Sysout, the order has been captured. That's it. And you have to call this method wherever you need. Order product dot order capture. Let's execute this application. So see, we are getting the output. The order has been captured. So let's park this explanation of functional interface and Lambda expression aside. And we will come again to revisit this functional interface and Lambda expression one more time. So introduction to method references. So Java provides a new feature called method references in Java 8. So these method references are new to Java 8 version. So the functional interfaces and Lambda expressions are prerequisites required in order to grip over method references in Java. So frankly speaking, these method references are extension to functional interfaces and Lambda expressions. So in order to learn or in order to expertise in writing method references, first you need to know how to write functional interfaces and how to write Lambda expression implementations. Without knowing functional interfaces and Lambda expressions, you are unable to write method references in Java. Apart from taking advantage of functional programming, one of the biggest advantages, apart from taking advantage of functional programming, one of the biggest advantage in using a Lambda expression is to minimize the lines of code. Actually, here we already know that functional interfaces, functional programming provides the concise code. That is, it will provide the developer to minimize the lines of the code. That is one of the biggest advantage of writing the functional programming. So using this functional programming, functional interfaces and Lambda expressions came into the picture, your code. And moreover, readability of code is also increased because if less code, if less lines of statements in your code, readability is also more. So this feasibility will be provided by functional programming. Means similarly, method references also minimizes the lines of code even more than Lambda. Already you know functional interfaces and Lambda expressions will reduce your code lines. And more than your functional interfaces and Lambda expressions, method references will provide less lines of code and more readability of your functionality. However, we use both of them in the presence of functional interfaces only. As I already told you, these method references are extension to functional interfaces and Lambda expressions. So while implementing the code for the functional interfaces, we have to put functional interfaces in your mind, and then only you have to provide implementation to that functional interfaces using the Lambda expressions. As I already told you, these method references are extensions of the Lambda expressions. That's why either you write your program by using the Lambda expression, or you can write your code using the method references. You have to put functional interfaces in your mind because both are used to provide implementation to functional interfaces only. Moreover, it is also a concise and simpler form of Lambda expression. So what I am saying is, if you use the method references, you can get more compatible code or more concise code than Lambda expression. So Lambda method references is compact and easy form of Lambda expression. And next one is, each time when you use Lambda expression to just referring a method, you can replace your Lambda expression with method reference. So method reference is used to refer method of functional interface. So in order to understand this point, first you need to see a limitation of functional interface and Lambda expression. Let's see what is that limitation if you use Lambda expression for your functional interface. So here I have one functional interface, order product. So this order product contains one abstract method, order capture. In order to provide implementation to order capture, I have to use Lambda expression to provide implementation. So I provided here. If I want to use this order capture method of order product functional interface in test class, what I need to do? I have to provide implementation to this abstract method by using Lambda expression. Then only I have to call this abstract method of this functional interface in the test class. Otherwise, I cannot. For example, I have one more class, test class. I have created one more test class. Test group. So I have main method. So in this test2 class also, I need to access the method present in the order product. How to access that method? So by using, first you have to provide implementation to this abstract method of this functional interface using Lambda expression in test2 class. After that only you have to access that method using functional interface reference variable. Let's create this order product is equal to, let's provide implementation to that abstract method using Lambda expression. Sysout the order has been captured, and then you have to call that abstract method of that functional interface using a reference variable of that functional interface. Order product dot order captured. See, here I have two classes. In these two classes, I can easily provide implementation to this order capture using Lambda expression. Then I will call easily. Let's think I have 100 number of classes. In that 100 number of classes, I need to use this order capture functional interface method. Then how to access that method? First, you need to provide implementation to that method using Lambda expression and then call that method in the all classes. That is one of the disadvantage. Means every time you have to provide implementation to that abstract method of that functional interface using Lambda expression, and then only you have to call that. So in all the 100 classes, you are duplicating that implementation. That's why method references came into the picture in order to avoid this duplication of the method. So by using these method references, you can create one method and provide that reference of that method to functional interface and then call that method wherever you need. That's it. See, each time when you are using Lambda expression to just referring a method, you can replace your Lambda expression with method references. You no need to write Lambda expression implementation to all the classes. Just write one method. In that method, you need to write your functionality and refer that method to functional interface and call that method wherever you need. That's it. Using method references, we get the benefit of code reusability as well. So let's write this implementation order product functional interface. So here I have a functional interface order product. I have one functional interface order product. Interface order product void order capture string product name. So in order to use this order capture in test class, I need to provide implementation for this order capture method in the form of Lambda expression. So writing the Lambda expression in all the classes is encouraging the duplication of the code. So in order to avoid that duplication, let's use method references. So let's take one separate class. In order to provide implementation to this order capture method. And after writing that method, reference that method to the functional interface and call that method wherever you need in all the classes. So class order capture info public static void order capture info method string product name. Sysout order of the product is product name. That's it. And here in the test class, instead of providing the implementation using Lambda expression, just you need to refer this newly created method to the reference variable of functional interface. Let's do it. Order product is equal to just a reference the existed method by using the implementation class. What is the class here? What is the separate class we have provided in order to provide implementation to the abstract method? The class is order capture info. And using this double colon operator, you have to provide reference. What is the method name? Order capture method. That's it. You no need to provide implementation using Lambda expression. And using this reference variable of functional interface, you can call that method wherever you need. Order product dot order capture. So my order is mobile. That's it. Let's execute this example. Yeah, see this, the order of the product is mobile. Let's quickly explain one more time. I have a functional interface order product. In this functional interface, I have order capture abstract method. So basically, I can provide implementation to order capture by using the Lambda expression. So in order to use this order capture in more than one class, I need to provide Lambda expression implementation to order capture in all the classes. At that situation, I can I have done the duplication of code. So in order to overcome that disadvantage, I need to write one implementation method, one reference method. So use that reference method and call that reference method with that class and assign that reference method to the reference variable of functional interface. And wherever you need and whatever the class you need this functionality, and call that method in all the classes. For example, I need this order capture functionality in some other method. So let's create one more class, new class. I have test2. In this test2 class also, I need order product functional interface implementation. Just I have main method. In this main method, let's write the code. First, we can write the code by providing the implementation using Lambda expression. So what is our functional interface? Order product is equal to, let's write our code using Lambda expression. Sysout product name, sysout the order of the product is plus product name. So call that method by using reference variable. Order product dot order capture mobile. See here, I have provided the implementation in the form of Lambda expression. For example, tomorrow I have 10 more test classes. In that 10 more test classes, if I want to use the functionality of order product functional interface, then all the 10 classes I need to provide implementation in the form of Lambda expression. So instead of providing the implementation of Lambda expression in all the 10 classes, just remove this Lambda expression implementation and you have to make use of method references. So I have already provided method reference implementation in test class. That is order capture info method. Just refer that method. That's it. So here order product is equal to order capture info double colon operator, and what is that method name? Order capture info method. That's it. You can call that method order product dot order capture TV. That's it. You can execute this method. So see, the order of the product is TV. I think you understand. I think by this you can understand what is the you can understand the limitation of writing lambda expression, and you have also understood how to overcome that limitation using method references. Next one, see, each time when you are using lambda expression to just referring a method, instead of writing the lambda expression to all the classes, you can replace your lambda expression with method reference. That is, you no need to write lambda expression in all the classes. Write one reference method and refer that method to that functional interface wherever you need. That's it. But here, using method references, we get the benefit of code reusability as well, because we don't provide implementation for functional interface. Instead, we provide references to already existing method to simplify the implementation of the functional interface using double colon operator. This process of providing reference to pre-existing method is called method references. So I think you understand what I have written here. So this statement tells about using the method references, we get the benefit of code reusability. Yes, we have already seen this code reusability using the previous example. Why we have get the code reusability feature? Because we don't provide implementation to functional interface using the lambda expression. Instead of writing lambda expression implementation, just you have to write method and reference that method in all the classes using the double colon operator. This process of providing reference is nothing but method references in Java 8. So there is one key point we have to put in our mind. That is, so pre-existing method should have same argument in number and type, and there are no restrictions on the return type as such. So what I am telling is, say in this referencing method, this referencing method is just a blueprint of the signature of abstract method that present in the functional interface. Say this abstract method of this functional interface is having only one parameter, and the parameter type is string. The same signature we have to follow to the referencing method to functional interface. See here in the line number 8, order capture info method is also having the same signature of functional interface method. So that is the one key point you have to put in your mind while writing the reference method. So types of method references. Types of method references. First, we will categorize these method references before knowing how to write them. In general, we have provided method references in 5 ways, sometimes called the types of it. They are method references to a static method of a class, method references to an instance method of a class, constructor references, method references of an arbitrary object of a given type, method references from a superclass method. These are all the types of method references. We will cover them separately in below sections. Let's go overall of these types through some simple examples. First one is method reference to a static method of a class. So we are going to provide method reference, but while referring, we have to take that method as a static method. We can refer to static method defined in the class. So see this syntax. So static method name. So this static method name is a reference method,
And what is this containing class? The class which contains this a reference static method. Let's see one example, then you can understand clearly. So say I have one functional interface. The functional interface name is single digit interface. This interface contains one abstract method, that is check single digit. This method is taking one parameter of type integer. And for this, I have provided one reference method in a separate class. This method is single digit. And this method has code implementation. So this implementation is all about, it is giving information whether that number is single digit number or double digit number. And in order to use this functionality in a test class, rather than writing this implementation in the Lambda expression, we have to just refer this existing method and assign this reference to the reference variable of that functional interface. Let's see this example. So this code snippet is all about writing your functionality in the form of Lambda expression. So say I have provided the code in the form of Lambda expression and assign this Lambda expression implementation to a reference variable of functional interface. And but here I don't need to write my functional, I don't need to write my implementation in the form of Lambda expression. Rather than writing this code in the Lambda expression, I want to prefer to write this code in the method references. See how to write your code in the method reference. Just refer this method, existing method, using the class name and assign this method references of this class name to the reference variable of functional interface. If you clearly observe how to refer this already existing method, already existing reference method by using the class name, because this already existing method reference is a static method. That's why you need to refer this method using the same class name. And you can call this method functional interface method by using a reference variable of that functional interface. Let's write this code in the IDE and check the result. I have a functional interface, single digit interface. In this interface, I have an abstract method, Boolean check single digit int number. As this is a functional interface, you can designate this functional interface using @functional interface annotation. Now, I am not using Lambda expression to implement this method. Rather, I have to use method reference. For this, you need to take a separate class and write the reference method. Class single digit. Public static Boolean is single digit int number. Return number greater than -10 and number less than 10. So if you observe here, each single digit is a static method. That's why this is a static method reference. Means referencing our function, means method reference to a static method of a class. First we can write our code by using Lambda expression. And then we will see how to provide our implementation using method reference. Using Lambda expression. So single digit interface S1 is equal to X return X greater than minus 10, X less than 10. Sys out S1 dot check single digit 10. This is the implementation using the lambda expression. And we can also see how to implement by using method reference. Using method reference. Single digit interface S2 is equal to, so rather than providing implementation using lambda expression, just you have to refer each single digit by using the single digit class. So as this is the static method, you have to refer this static method using the class name. So what is the class name here? Single digit, double colon operator, right method name is single digit, and call this method wherever you need. Sys out S2 dot check single digit. That's it. Let's execute this example. So first is false. 10 is not a single digit. Next 9 is a single digit. That's why it is showing true. Next one is method reference to an instance method of a class. Like a static methods, you can refer instance methods also. So previously we can refer that method by using the class name, because that referencing method is a static method. If you don't want to take the static method, then you have to reference your method using the object name. See the syntax. Instance method name is a method of instance method name is a instance method. It's not a static method. How can you refer this instance method by using the object name rather than using class name? See the small snippet of code. So I have a functional interface, addition interface. In this method, I have one abstract method add, which is taking 2 parameters. And I have one more class which has a reference method. So this reference method is sum, and it has provided implementation. And in the class test, I have created the object for this addition implementation class. And this is the lambda expression actually, but writing the lambda expression is encouraging the duplication of the code. That's why we have to use method reference. So how can you reference your sum method? By using the object of addition class. That's it. Let's see this example in the IDE. Interface, addition interface. This interface contains one method, void add int x, int y. So I need to provide a separate class in order to provide a reference method. Class addition. In this, public void sum, int a, int b. Sys out, the sum is plus a plus b. First, we can see how to provide implementation using lambda expression. Then we will see how to write method reference for the instance method. Create object to addition class. Addition is equal to new addition. Next, provide implementation using lambda. lambda expression. Addition interface I1 is equal to, let's write in the form of lambda expression A, B. Sys out, the sum is A plus B. And you can call that method I1 dot add 10, 20. And rather than providing implementation using lambda expression, let's try providing implementation using method reference. Using method reference. Addition interface I2 is equal to, instead of writing the lambda expression, just refer the instance method of addition class. As the sum method is a non-static method, you have to reference using the object. Addition double colon operator sum, and call this method wherever you need. I2 dot add -1, 20. That's it. Let's execute this class. See, first sum is 30. Using reference variable is 90. That's it. Next is constructor reference. When single abstract method returns type is any object, we will go with constructor reference. So actually, our functional interface abstract method return value is object, then we have to go for constructor reference. You can refer a constructor by using the new keyword. See the syntax here, new is a reference constructor, and this can refer by using the class name. See, I have one interface, interface 1, and this functional interface contains get employee method, and this method is returning what? Employee object. I have one more functional interface, and this interface has method get employee with 2 parameters, and what this method is returning employee object. So as these 2 methods are returning the employee object, I need to create employee class, which contains 2 constructors. One is empty constructor and another one is argument constructor. See, in the test class, I am using method references. So while using the method references, I can refer here new keyword rather than method reference. I can use only new. So this new specifies the constructor reference. So here I have one more constructor reference, but here this constructor is taking parameters. So I3 constructor reference is the constructor without any parameter, and I4 constructor reference is the constructor with taking parameters. That's it. Let's see this code in IDE. I need to create one class employee separately. Employee. So see, this employee class contains string name, int age, and I have one empty constructor, Alt Shift S O. This is empty constructor, and I have one more parameterizer constructor, Alt Shift S R, Alt Shift S O. And next, I have one method, void get info. In this, I have sysout this is a method of employee class. I have two functional interfaces. Interface 1. This interface contains public employee get employee, and I have one more interface. Interface 2. Employee get employee. String name int age. So here how to provide implementation using method reference. So first interface I1 is equal to employee double colon operator new. So I1 dot get employee dot get info, and next one is interface 2 I2 is equal to employee new. Just you have to refer your constructor by using the same class. And the next one I2 dot get employee Mannem Prasad 30 dot get info. That's it. Let's execute this application. So see, this method is a method of employee class, this method is a method of employee class. We can get output for the both. And next one, a reference to an instance method of an arbitrary object of a particular type. So this is little bit confusing. Actually, like a static methods, you can refer instance methods also. But in the following example, we are describing the process of referencing the instance method. See here, I have instance method. I am referencing the instance method. But how to referencing this instance method? Arbitrary object type. What is this arbitrary object type? So look into this example, string double colon operator to uppercase. Usually, to uppercase method is called on a string reference. But we have written class name string as like reference to static method. See here, so to uppercase method, we are calling from the string class like a static method. But who has created this string? Already predefined string class, rather than you created this class, which is nothing but arbitrary object, means instance method of arbitrary object of particular type. So in the following example, string is a particular type and the arbitrary object is the instance of a string. So see, here string is a arbitrary object of instance of string type. When reference to an instance method of an arbitrary object of a particular type, that invokes a method onto a current object. So see, to uppercase is a instance already existed method from string class. So I am getting the benefit of this to uppercase method from the string class, which is nothing but an arbitrary access. So let's see this example in the IDE. I have a functional interface my functional interface. In this, I have a method string process string name. So instead of you writing a reference method, just you have to make use of already existing method of existing class, which is nothing but a arbitrary access or arbitrary reference. My functional interface f1 is equal to s dot to uppercase. My functional interface f1 equal to string double colon, we have to use to uppercase method as a reference method, which was already existing in the string class. Even string class is also a predefined class. Sysout f1 dot process string Mannem Prasad. That's it. So see, I get the output in the uppercase. Next, to superclass and chain class method using super and this keyword means how to access superclass and chain class methods using super and this keywords. See this example. I have a functional interface A which is having abstract method say hello, and I have one separate class which is having a reference method super hello method. This is just printing a string. And next one, say I have child class which is extending that super class. And this is a separate method, child hello method. And I have one more method, test hello. Now we are going to see how to access the super class method by using the super double colon operator called the super hello method. This super hello method present in which class? Super class. See, this is a super class, super hello method. And like that, how to use the current class reference method by using this. See, this double colon child hello. What is child hello method? Child hello method is the same class method. So this is how we can access the reference methods of super class as well as a same class. See this example in the IDE. I have an interface A. This is having void say hello. And I have one separate class, a reference class. This is class super class. This is having a reference method public void super hello. Sysout I am this method is in super class. So see, I have a child class of super class. Class child class extends super class. I have a separate method public void child hello. Sysout this method is in child class. I have one more method public void test hello. A1 is equal to super. How to access the super class method? Super hello. A1 dot say hello. At the same time, how to access current class? Current class method A2 is equal to this double colon operator child hello. A2 dot say hello. That's it. Let's write it in main class. child class is equal to new child class dot test hello. That's it. So see, this method is a superclass and this method is a child class. That's it. Method references. Method references are type of Lambda expressions that are used to simplify reference a method in their call. With them, writing code can be a lot more concise and readable. We have seen so many number of examples. Next, Lambda expressions have introduced Java developers to a more functional approach in programming, which allows them to avoid writing verbose code for simple operations. Did you like our effort? If yes, please like and subscribe to Mannem Java Central and share this video to your friends, those who are struggling to learn method references in Java 8. Thank you. Please subscribe, like, and share. And please like Mannem Java Central on Facebook.